So let's hit record. Yeah, okay. So S then is equal to K times W. And then we plug in H squared. That's 4R squared minus W squared. So now differentiate that and set it to 0. Because, right, that's how we maximize or minimize something.
Yep.
Yeah, but how do you derive KW?
Well, K is a constant. What's the derivative of 2W?
It's just 2, right?
So in this case, it would just be K.
Geez, they're just treating it as a number. All right, cool.
Right, so we leave that part alone. Then plus, now do the other part.
So
leave
8R
KW.
minus
And
2W.
what do you get for the derivative of the other part?
8R minus 2W. Something. I'm not sure.
It'd just be 2H, wouldn't it? No.
Just be that.
That says plus KW.
Yeah, that says plus KW. Sorry, I'm
You're
my
fine.
computer standing up and it keeps moving. Plus KW.
Plus KW minus 2W.
Now, does it make sense that when if I tried to differentiate R, it would be 0?
No. Why would it be 0?
This is a rigid object, right? It's
Right.
it's some log, right? So the radius of the log can't change.
True.
So if I try to differentiate it, it would go to 0. So solve that for W. And once you have it, plug it back in right there and get H. So I'll do it here on the board real quick behind me while you guys are working. Okay, tell me what you get.
I don't know if I'm right, but I got 4KR squared plus KW.
Can you say that again? Sorry.
I got 4KR squared plus KW.
I think there's no, I'm just saying I think there's a minus sign that you're missing.
Oh yeah. I wrote it as a plus. So it's 4KR squared minus 3KW.
Should be KW squared, right?
Yes, that's what I meant. Minus 3KW squared.
Yep.
Okay, now I'm good.
So you had that, so that should get you your equation for W squared then should be 4/3 R squared.
What?
Do you want me to give you a few more minutes, or do you want me to share with you?
I don't know what I'm supposed to do after I got my equation.
Solve for W.
Okay. Because you already know what h squared is. So now I'm solving for the W.
Well, you're going to solve for W in terms of the radius. And then you're going to plug it back into the h squared equation that we came up with and solve for h.
Oh.
Anybody else want to share what they have so far or ask any questions? You sound mad.
I don't know if I get it. I don't know if I know the steps of how to optimize. So when I go through the problems, I don't know what's supposed to come next. And I don't think this is a great problem for me to start off with.
This is a really good problem.
Yeah. Good for people who know what they're doing.
Well, I set it up for you, right? So you should have you solve for W over here.
I think the problem is there's no numbers. I just don't even know where to go.
Yeah.
Like,
I'm just kind of
just
looking
stop,
at it.
like, I have like
Yeah,
a full house
I'm
square
just
here,
looking at
and I
it.
stop. Like,
All right, so look. I want to solve for W. Right, the problem says find the strongest beam that you can.
Mm-hmm.
And they want to know what's the width and the height then. So I'm going to take this equation that we had and solve for W. So this would be, now everything there is equal to, let's see, can I get a different color? What's this thing do? Everything here is equal to 0, right? So this K and that K can cancel right away. I could just divide through by K. So then I have 4R squared minus W squared minus 2W squared, which comes from this,
Mm-hmm.
is still equal to 0. Or 4R squared minus 3W squared equals 0. Oof. And if you solve that for W, or W squared first, you would get 4R squared over 3. And if I want W, well, then I just take the square root. So that would be 2R over the square root of 3. That's W. Okay. You don't agree with what I solved for? Or,
You solve for W squared by just taking out the W squared.
I moved this 3W squared to the other side of the equation.
And then divided.
And then divided by 3.
It is so early.
like, I kind of get it. I just don't know if I get it right. I don't know. I kind
think
of
I
get
got
it.
So that's W. Now we also need H. Right? Because the whole point is we want the strongest beam, which means I need W and I need H squared. So I don't even really need H. I just need H squared. So H squared is equal to 4R squared minus W squared, which I have right there, which is 4R squared over 3.
Right. Perfect.
So that's 3/3 minus 1/3 times 4R squared, if you will. Right, this is, if I factor out a 4r squared, it's just 1 minus a third.
Okay, I see what you did.
And
Yeah,
this
this is now coming together.
So we
This is
have the
just
h
2/3.
squared. We're trying to get down to just the h. So
Well,
you
in this
took what
case-
we.
This case, I only really need h squared
Okay.
because, right, I can plug in h squared here and be done.
Okay, and so you took the equation that we found for h squared earlier
Mhm.
and plugged in the w squared.
Yep, and then I substitute this in. So
Okay.
h squared then is 8r squared over 3. Now, take w and h squared and plug them back into s. So s equals k times w is 2r over root 3. H squared is 8r squared over 3. So it looks like 16r cubed over 3 root 3. So really weird looking, but that's what it wanted. And again, I get it. There's no numbers plugged in. But if you could do this with variables, then you can obviously do it with numbers.
True.
So let's see if we can do the second one.
Whew. All right. Is everybody else done with the first one?
Yeah, I'm good.
I'm good.
So I'll just do it. I'll erase the marks then.
I'm substituting.
All right, so 8-foot fence stands 5 feet from a tall building. The contractor needs to reach the building with a ladder from the outside of the fence. Find the minimum length of the ladder that can do the job.
Okay.
So any suggestions on where to start?
Probably finding. I don't know. Oh boy. Probably finding the rest of the values and like the triangles and all.
So what is it asking for? It says
We're minimizing.
minimum length of the ladder.
Right.
So we
Yeah.
want to know, what is this length?
Right. Being 100% honest, if this was on the test, I'd probably look at it and just think, what's the next one? Because this just doesn't seem like there's enough information to even solve.
It's so true. You don't even know where to
So-
start.
What kind of shapes are we dealing with?
Triangles.
Okay. How can I relate that length to anything else given in the picture?
It's, I mean, we can use the Pythagorean theorem again,
Yeah.
but that's all I know. 8 is one of the sides of the small triangle.
Mm-hmm.
It's obviously a 90-degree angle, so which means you can do that. No. Oh, man.
So I'm thinking maybe something with a relationship between two triangles.
Is that a thing?
Remember, there's the relationship with similar triangles.
Didn't
Let's
know
just-
that.
Let's just write down everything we have.
Okay, sure.
So
Let's
we've
start with
got
That's a good idea.
if we want to do this triangle, right? I'm going to call this the height. I'm going to call this the length. And because we don't know this little section, I'm going to call it X. So that would tell me that L squared has to equal H squared plus 5, whoops. That needs to be 5 plus.
plus x squared.
5 plus X squared. All right, we also have this little triangle here. So that one has that, whatever this distance is. I don't know, I guess we'll call it Y, because I don't have any other variable off the top of my head. Y squared has to be equal to 8 squared plus X squared.
Okay. So
And the last things that we have, remember I said that there's stuff for similar triangles. And so that means basically if you have triangles that have the same relationship between the sides, so they scale the same,
mhm,
which is obviously the case if we have a triangle within another triangle.
right.
So that means that this length, let's say with relationship to that length,
Is the same as h to
would
5
have
plus.
to equal this length as the same as that length.
Okay.
So we could, when I say that length to the other length, we can do a division. So 8 divided by X has to be the same as H divided by 5 plus X.
Okay.
Right. Anything else that we can get from the picture?
Mm,
Let me just clean this up a little bit.
whatever that degree is, isn't it the same for both triangles?
This angle here,
Yes.
it would be, yeah.
Not that we know, but it would be the same.
So that's actually where this thing comes from, right?
hmm
Because if I said the cosine of that angle
Right.
would have to equal X, actually, sorry, the tangent, X over 8, or 8 over X, and then another one would be 8 over plus X.
Right. Okay, that makes sense. Mm,
So the question is, do we have all of the equations we need to be able to solve?
I think so.
Hmm.
Reach the building with a ladder from outside the fence.
Problem is that I see 4 unknown quantities and only 3 equations. So we need some other relationship here.
Okay.
So any other suggestions?
Mm, something to do with the 5 and the 8.
Actually, I think these two equate. Oop, come on. I think this will be enough, actually, these two. Right, we are trying to minimize the length of the ladder, which means we're going to differentiate this. So L isn't going to matter because I'm going to set it to 0.
Okay.
So I have an equation here that has H and X. And this equation also has h and x.
Okay.
So let's solve this equation for h. And then we don't care that this is L squared. We can still maximize or minimize that. Recall that we did the problem with the distance between a curve and a point, and we actually minimized the distance squared as opposed to the distance.
Okay.
So we can just differentiate this L squared quantity. So we can just say DL squared. And of course, the height of the building is not going to change. So we're taking the derivative with respect to x here. Hold on, let me think about that. Yeah, that's right, because we're going to plug h in. So yeah, h has this relationship with x, right?
Right.
So h squared, I was jumping the gun. It's going to be, let's see, how do I want to write this? I guess let's write it as 40 over x plus 8
Okay.
squared, I guess.
Squared because h
Because
squared.
h squared, yep. So I just simplified this guy to 40 over x plus 8. I'm going to then plug it in there. Just put my squared in the wrong spot. There we go. And now take the derivative of this thing. So I'm going to get 2 times 40 over x plus 8. Yes, I know. We only have 10 minutes left on the chat. Thanks a lot. All right. And then the derivative of the inside. So that's x to the minus 1. So we would get minus 40 over x squared out of that.
X to the minus 1 because x is in the denominator.
Mm-hmm. The derivative of this next one is 2 times 5 plus x. And then derivative of x is just 1, so no need to write that. And then this whole thing has to be 0. So right off the bat, let's get rid of these. And I guess let's go ahead and multiply that out. So we've got negative 1600 over x cubed minus 320 over x squared plus 5 plus x. That's awfully ugly, isn't it?
Yeah.
I wonder if I multiply by x cubed, if that'll work. Let me see. Thinking maybe I should have taken the derivative in a different form to make this easier to solve. See what happens if I try to group these. Would you look at that?
Okay. So
Was that I have no clue what you just did?
no, I was following you. It was just like
So at this step, I multiplied through by x cubed on both sides, right? So I got this next line. And then the next line, I grouped these two, and I grouped these two. Now, of course, this one is right here. So I factored out x cubed.
right.
I left behind x plus 5. And if you take out a negative 320 out of this other one, you also get x plus 5. So x cubed minus 320 is one of the factors. The other is x plus 5. Obviously, x plus 5 does not work because that's going to give us negative 5, and we can't have a negative length.
Right.
So what is the cubed root of 320 is the question. Oops.
Mm. 6.839,903.
That's good enough. So not a pretty number, but that would be x. And then once we have x, if you want to find L, right, you would just do h squared plus the 5 plus x squared. So L equals the square root of,
I have a question.
yeah, good.
Where did you get the x cubed? All the way back. I see it in the denominator, but it wasn't. You just took the largest power and multiplied the whole thing by it.
Yeah, that way there was no fraction.
Okay. What does that do to the? I mean, apparently it just makes it 320x.
Yeah, the only thing you have to be careful of is, this equation tells you that you can't have x equals 0.
Mm-hmm.
So if you multiplied through and then all of a sudden you got a solution is 0, you have to realize that that's not okay.
Okay. All right. So then we did.
So that would be your answer for L, whatever you get out of that calculation. And I took that from this right here that we came up with earlier.
Right.
Took the square root, and then I just plugged in h squared and x everywhere.
Let me plug it in.
So everybody else following, or you just chilling? Everybody still here?
Yeah, no, I got it.
I got it.
Yeah, no.
Yeah, no.
Yeah, no, I got it. Yeah, no.
A little bit.
Oh, boy.
So I think the one that I gave you guys was another cardboard cutout like box problem. Was that right?
Yeah.
So you could use the same setup as we had in class, right? You have your cardboard, you cut out the X pieces. You call these X by X, and then whatever this length is. You have
Let's start doing. Let's
this.
start by doing this.
So it would be 20 minus 2x for that length. And then let's say this was 30. So this would be 30 minus 2x for this length here. And then your other dimension would be x. So x times 20 minus 2x times 30 minus 2x. And then these two things here have 2's in them. So it would be 4x, 10 minus x, 15 minus x, just for an example. And then you got to differentiate that. If you really want to, you could multiply through the whole thing, FOIL it out, then differentiate. Just get x out of it. Once you have x, find the other lengths.
So my question is the question on the test going to be like these or like that one?
It's going to be somewhere in the middle.
Interesting.
Sweet.
Right, because the box problem, you've done it now twice.
Right.
Yeah.
You should be able to just write the equations and go to town.
Right.
These problems are pretty tough, which is why I chose them. Because if you can understand how to do these, then you should be fine with anything I give you.
All right.
And
Fair
I
enough.
love these problems because they really make you think. Right, you gotta delve back into trig and algebra and any kind of relationship you could possibly think of.
I think the hardest part about them is like making the equation, like
That's
knowing
true.
which letters to make the equation.